In the southwest United States, the climate keeps changing. Wetter or drier, warmer or cooler. In fact, long before the white settlers came to Arizona, drought drove many American Indians from their homes. Go to the right places and you can find out what the weather was like hundreds of years ago, because the trees remember well. Their trunks preserve a record of their lives. Sometimes they grew vigorously, sometimes life was hard. To Harold Fritz of the University of Arizona, the trees of North America reveal the changing climate over large parts of the earth. Here's the autobiography of a ponderosa pine, written in the varying rings of annual growth. But you need to know how each species grows, how heat or cold, rain or drought can combine or contradict each other, how the winter can affect the summer's growth. The sources of water and shade matter too, and you have to sample thousands of trees at many places. The Laboratory of Tree Ring Research compares and contrasts the experience of different trees in different sites at precisely figured dates. Ring by ring, year by year, the measurements go on to computer tape. The more recent ring widths can be related to well-recorded weather. Then you can use older rings to make a picture of conditions in our forefathers' time and ask how the weather machine was working decade by decade, year by year. At the time of the gold rush of 1849, the trees of Southern California grew poorly, with narrow rings. But trees in Colorado had a spurt of wide rings. Storms evidently brought in the rain along peculiar tracks. Today, a computer maps the climate. To produce and guide the storms of that time, aberrations in weather patterns stretched right across the Pacific. Eventually, they deduce solely from the information from the trees the weather of 1849.
Up here in this area of low pressure, which are conditions which would cause more than normal precipitation and rather muddy going for the 49ers crossing the country at that time.
Now, Professor Fritz is extending his work eastwards across North America. This sample's from Missouri, and with tree ring experts in other countries, he's pursuing the former weather all around the world. There are other ways of exploring the climates of past centuries. The River Thames. It used to freeze from time to time, especially when the ancient London Bridge clogged the stream. Recent centuries were, for Europe, a good deal cooler than today. Historians of climate call them the Little Ice Age. Ships came home to Greenwich with weather records from distant oceans. Knowing the winds of the world was a matter of life and death aboard a sailing ship. And nowadays, knowledge of the world's winds in centuries gone by is crucial for understanding past and present changes in the climate. No one's argued that more strongly than Hubert Lamb.
In 1536, King Henry VIII drove all the way down here to Greenwich on the frozen river. But in the region of Moscow, the 1530s were unusually mild. That doesn't make much sense till you work out how the winds were blowing. Then you find that the jet stream could guide warm air towards Moscow, while it brought cold air towards London.
Historical information about the climate is scattered in old documents. At Greenwich, the National Maritime Museum preserves some of the ship's logbooks. Conditions that sailors faced long ago become telltale symptoms for Professor Lamb and his climatic research unit at Norwich. A warship outward bound for the Pacific 150 years ago. She took the temperature of the Atlantic as she went. Records of this sort show, for instance, that the great warm current, the Gulf Stream, didn't follow its present track across the Atlantic. it flowed further to the south.
During the Little Ice Age, the Arctic zone expanded and pushed all the other zones of climate southwards. So places like London and Amsterdam, for example, had the sort of climate that nowadays belongs 200 or 300 miles farther north, in the far north of England or southern Sweden, for instance. At the time when these splendid buildings were put up, the Atlantic storms were coming in near Scotland rather than near Iceland, but there were east-west changes too. In recent decades, the jet stream has strongly guided warm air into Europe in winter. In the Little Ice Age, the jet stream was weaker and farther south, and it made shorter and wider zigzags on its way around the world, often funneling Arctic cold air into Western Europe. Now the winds are changing again in our own time. Increasingly, they resemble the wind patterns of the Little Ice Age. As it happens, we've just had 4 mild winters in Western Europe. But overall, the signs are not that way, especially as regards the extent of the Arctic ice. We should be preparing ourselves for a long period of mainly colder seasons, and also more variable seasons. The Little Ice Age lasted more than 300 years.
Now it may be starting again. Glaciers are slow thermometers of climate. During the Little Ice Age, they advanced down their valleys. Earlier in our century, the glaciers melted back. Is there any rhythm that might tell us whether the glaciers will advance again? One man who thinks so at the University of Maine is George Denton.
Our work with glaciers has shown a series of little ice ages separated by about 2,500 years. Each of these little ice ages has lasted from 800 to 900 years and has included several periods of warmer weather. The most recent of these little ice ages began about 400 years ago, and even though we've had warmer weather during this century, it's quite possible that we may revert back to the colder climates of this little ice age.
Already, the Russians are building icebreakers as fast as they can. Perhaps the Gulf Stream, which sweeps warm water towards northern Europe, will swing southwards again, like a door half closing, and travel as it did a couple of centuries ago. And the tree ring researchers have found in the old trees in California evidence of cool and sometimes wet conditions during the Little Ice Age. They're just what Professor Lamb in Europe deduced from the worldwide link of the jet stream of the upper air. The ever-moving air and oceans can slip into different habits. Some experts think they give the weather machine plenty of chances to change the climate just by its own whim, as it were. But there may be outside causes. The advances of the glaciers every 2,500 years are connected, curiously enough, with the amount of radioactive carbon in the air. It increases and diminishes in step with the glaciers. Changes in the sun affecting the natural radiation falling on the Earth are the most likely reason. Maybe the sun slowly blinks and so changes the climate on Earth. Some of the coldest summers of the past few centuries have followed big volcanic eruptions, in Indonesia especially. Volcanoes put dust high in the atmosphere and reduce the sunshine for a few years. But we can't forecast volcanoes. The sun's variations, if they're real, are cryptic ones. In any case, human activities are already affecting the weather, and perhaps we're accidentally helping to change the world's climate.
Okay, it's ready to go.
The Metropolitan Meteorological Experiment. 6 American laboratories are joining forces for 5 years to find out how urban man affects the weather.
47.2 and 39.5.
They chose St. Louis beside the Mississippi River. Gateway to the West, the pioneers called it. Today, its inhabitants unwittingly alter the climate a long way back to the east. Understanding St. Louis may explain effects of human life and industry in other places. As shown in false colors in a picture from space, the city increases the clouds down the prevailing wind, making extra rainfall in the area. There aren't many clouds around today, but there's one here.
Small convective cloud forming over the refinery. Cloud base 3,100 feet. Good visual plume off the refinery. Okay, starter, Stan. We're in it. Start the bag.
A team from the University of Wyoming samples the polluted air.
This petrochemical odor is just overcoming here. It's just very strong.
They're policing the city and its weather more thoroughly than anyone's attempted before. The aircraft coordinate their work with units on the ground.
Stand by for some aerosol sampling, please.
This is KTE.361, Unit 2 from 21. We are pulling up here on the arch and we'll be setting up here.
Each summer, St. Louis is besieged with instruments. Mobile weather stations monitor the wind. They measure the dust particles that human beings add to the air, and they check the air's humidity. The city increases the rainfall in nearby areas by 30% in summer. Watching over the countryside around St. Louis, radars track the rain clouds. From the Illinois Water Survey, Stanley Changdon dreamed up this intensive study of a city and its weather. His radar records show rain clouds developing over the city and moving away downwind. Other scientists prefer to visit the clouds in person. In this speeded-up film from a research aircraft of the University of Chicago, we're seeing some of the typical clouds that drench the countryside downwind of St. Louis with rain and also hail. After each summer's work, the experimenters go over their records.
This is the one down here. Now,
The Chicago team operated a radar in the heavy rainfall area. The film record shows precisely when each cloud began to rain from successive pictures. They help in tracing what causes the extra rain.
isn't that nice?
Chiefly, St. Louis seems to increase the chances that existing natural clouds will shed their rain. Industrial pollution makes them rain more intensively. But the balloons and aircraft have also charted a high dome of warm, dry air forming over the city as the sun beats down on roofs and roadways. It causes passing storm clouds to grow larger. So human ways of life affect the weather locally. But do our furnaces and factories, like these in England, have wider effects? Our homes, too, put smoke and dust into the air. Could it add up to a cause of the present changes in climate around the world? The sternest critic of human activities and their possible impact on climate is this visitor to England, Reed Bryson from the University of Wisconsin.
Man-made dust may account for some of the climatic change that is now occurring. In the past, climatic changes were largely due to volcanic activity putting large quantities of dust into the atmosphere. Volcanoes have been recently quiet, even though the climate is changing now. And I believe that part of the reason is what I call the human volcano. A man-made dust pall is spreading over the earth. Here in countries like England, we're used to blaming industry. And that's probably right. But there is also dust produced by overuse of the land farther south in the subtropics. There, the use of the soil in a dry country produces dust which the wind blows into the air. And in other regions, the burning of forests to clearing fields makes great quantities of smoke. This dust, all added together, spreads around the world, blots out the sun, and causes cooling on a worldwide scale. That, unfortunately, moves the subtropical deserts farther southward, and this suppresses the monsoons of Africa and of India. Not all scientists agree with this theory. I hope it's wrong myself, but there is no doubting its seriousness, for if this is correct, millions of people will be destined for chronic famine.
But when we burn fuel in our fires and engines, we also put extra carbon dioxide gas into the air. That could have the effect of warming the earth. On Arctic routes, airline engines suck in air for the cabin. It's meant for the passengers, but it's also a convenient sample of very clean air. For routine measurements of the amount of carbon dioxide in the atmosphere, this same supply serves very well. Swedish scientists have been using it for that purpose for several years. Nature's carbon dioxide helps keep us warm. It's like the window of a greenhouse. It lets sunlight in while it also traps heat rays trying to escape from the earth. And in a Swedish forest, the researchers pursue the carbon dioxide as it takes part in the life of trees. Forests help to regulate the amount of carbon dioxide in the air. But if we release too much carbon dioxide, will we overheat the world? For Bert Bolin of Stockholm University, it's a taxing question about a piece of the weather machine that also involves living trees.
Trees grow more quickly for an increasing amount of carbon dioxide in the air. And of the amounts that man has put out into the atmosphere, about 10% may therefore gone into trees like these. Of the remainder, probably about 1/2 has been absorbed by the water, by the oceans, but another half almost remains in the atmosphere. And this means that the carbon dioxide content of the atmosphere has increased by about 10% since the latter part of last century. And for this reason, we think that the climate is somewhat warmer today than it would otherwise be. And there is a lot of oil, and there are vast amounts of coal left. We seem to be burning it with an ever-increasing rate. And if we go on doing this, in about 50 years' time, the climate may be a few degrees warmer than today. If it would be warmer like this, the oceans would be able to absorb less of the carbon dioxide, and the heating effect might reinforce itself. Others say, however, that a warmer climate would mean more clouds, and the clouds would reflect more of the sun's rays back to space, and therefore it would be cooler. Again, others say that the heating effect of the carbon dioxide would be nicely balanced by the increasing amount of dust that man puts into the atmosphere. We just don't know. Let's therefore keep an eye on the amount of carbon dioxide in the air.
The world's carbon dioxide has been checked continuously only at one place, Hawaii. 11,000 feet up the side of a volcano, the Mauna Loa Observatory sprawls on the bare lava like a moon base. In mid-Pacific, swept by clean winds off the ocean, the observatory records only the most lasting effects of pollution. It's a breathalyzer for the planet. For 16 years, a key measurement has been of the carbon dioxide. The Pacific air, sampled in this tube, shows how much carbon dioxide it contains by its power to absorb heat rays. The men who tend these instruments can see the whole world breathing. Plant life in the northern hemisphere dominates the picture.
Oh, the tree's getting steady now. Looks much better.
Okay, I think so. I think we got a...
The carbon dioxide rises during the northern winter, falls during the summer. Plants grow, plants rest, grow and rest. But the overall trend is upwards, and it bears out Bert Bolin's view that carbon dioxide from man's fires and engines is building up faster than ever. Unchecked, it could one day overheat the Earth. But the Earth's cooling just now, at least in the north. Reed Bryson blames that on the human volcano, on man-made dust and smoke cutting out the sunshine. So what's the verdict on the dust here at Mauna Loa? A row of instruments track the sun. They record its changing brightness as it slants at different angles through the atmosphere according to the precise time of day. An automatic clock paces the automatic instruments.
55 minutes, coordinated universal time.
The years of records show the dust of real volcanoes. In 1963, a big one at Bali. But now the dust's no greater than 15 years ago. There's little sign of the human volcano here in mid-Pacific, at least. Even so, they like to take a better look at the dust. With a new instrument, the observers can make out layers of dust floating many miles overhead. They use a laser beam.
Okay, I think we can try a shot now. How's that?
Okay.
Particles of dust light up in the beam at different heights. When the trace is interpreted, it tells of a natural layer of particles 12 miles up. But some dust detected here in Hawaii has come all the way from the drought lands of Africa. Pasture was never lush near the desert's edge, but in some herds, less than half of the animals survived the deadly years of the early 1970s. And trees died too, all along the Sahara's southern edge. The summer rains require moist winds from the ocean, and the air must rise to shed its water at the right time. In recent memory, the process worked well and farmers prospered, until the years of drought. Some experts reason that the desert's coming southwards because the earth is cooling, and that could go on for 50 years. If so, several entire nations may have to be evacuated in the end. Some of the neglected or unlucky people died. Most refugees found sanctuary in camps near the towns. They depended almost entirely on gifts of food. These victims of the fickle climate live in the young nation of Niger. Will they ever grow their own food again? In 1974, the rains were better. The government of Niger decided that the 7-year drought had ended and the refugees must go home, back to the desert's edge. What the years ahead hold for them back in their villages, who can tell? Those dire predictions of an ever-advancing desert may be right, or they may not. Any attempt at forecasting changes of climate meets skepticism from the men who modeled the weather by computer.
In making decisions which affect people, a bad prediction as to what the climate of the future will be can be far worse than none at all. I'm afraid that our understanding of the complex weather machine is not yet good enough to make a reliable statement of the future.
At the Geophysical Fluid Dynamics Laboratory at Princeton, Joseph Smagorinsky and his colleagues are preparing an exceptional computer for an exceptional task. It's 10 times faster than the already very big machines used for routine weather forecasting. Here, it's wholly devoted to research on our weather and climate.
If you were to claim catastrophe because industrialization is pouring dust or carbon dioxide or heat into the atmosphere, I could just as easily offer a counter-argument. This is merely a reflection of the fact that the atmosphere is a very complex physical system, one which is yet imperfectly understood. Common sense or scientific intuition alone will not resolve the difficulties that we face. In order to do the job properly and reliably, we've got to use the large computing machines.
Outstanding meteorological theorists have clustered around the big computer like bears around honey. Some use it to consider how cities affect the weather. Others are studying the climates of planets quite different from our own.
The interesting thing about the planet Jupiter is that it receives less heat from the sun.
They may help to reveal peculiarities of the Earth's climate.
The question is whether
Others again want to calculate how man-made pollution gradually disperses itself in the atmosphere, or else to sum up the awful violence of a hurricane. These theorists include quite a substantial fraction of the Japanese population of Princeton. Syukuro Manabe has the most ambitious program of all. He sets out to simulate the Earth's climate well enough to explain past changes and eventually to predict future ones. And Kirk Bryan deals with the slower weather of the oceans.
As simulated by Joint Ocean Atmosphere Model, now to be...
They're making their model air and model ocean react to each other. That's necessary for any thorough description of the climate. It's tricky, though. Bryan's ocean changes far more gradually than Manabe's air. They really need a computer 1,000 times faster still. Meanwhile, not just in Africa, but in India too, human problems are pressing. The wind blows dry for half the year in central India. The weather machine must contrive a great overturn to bring rain to these fields. For 9,000 years, farming communities in India have waited each summer for the monsoon rains to begin. They always come, but sometimes they're late or inadequate. The country's population has grown hugely during the middle part of the 20th century, an era of reliable monsoons. But will there always be enough water for India? That may be the grimmest question of all about our changing climate. A series of droughts could defeat India's efforts to feed herself. The monsoon was poor in the mid-1960s, and in 1972, almost a third of India's food was lost. If the rains are late, the villagers fear the gods are angry. The whole village musters to appease the gods with the ancient hymns. And they beg the god Indra to launch his thunderbolts against the demons that hold back the rain. For 100 years, the Indian Meteorological Service has confronted the vagaries of the monsoon with whatever tools came to hand.
So find the monsoon trough is like
Nowadays, that means computers, and it means picking up the satellite pictures.
Horizontally nahi kar rahe hai.
The rain-bearing clouds massed first in the south of the country. How the monsoon actually works is still a little mysterious.
East-west, and these two low-pressure areas very prominently manifesting there. And the western
The summer wind sweeping off the ocean covers India with moist air. Nature has next to trigger the rains themselves. That requires not so much the thunderbolts of Indra as the depressions that move into the mass of moist air. In 1973, the depressions worked well, but 1974 brought severe floods in Bangladesh, while in central India, the rains were grievously delayed. They were a month late in some places. While the farmers waited for the water from the sky, the depressions failed to come. And when at last rain materialized, it was only a shower. Far more rain than this was needed to quench the thirst of dried out fields. In this region, floods came, but 6 weeks later. Experts strive to read the riddle of the rains of India by computer. In Princeton, Sukuro Manabe has mimicked the main features of the monsoon in his model of the Earth's climate. Now, Jagadish Shukla, himself an Indian, helps to make the model monsoon more realistic.
did you actually look at where
They can't yet explain the year-to-year variations, but they're using the computer for a series of experiments to test theories about what governs the monsoon. The temperature of the sea off Africa affects the rain over India in their model, and they moved mountains to see how they figure in the story. The computer is given a simplified version of the Himalayas. From this, it calculates a rainfall pattern for July. But in central India, it shows less rain than in the real monsoon. It's easy to make the model worse. The experimenters change the computer's picture of the world by taking out the mountains, and as they go, a vast desert straddles India. The model Himalayas exert a big influence, so put them back, and as one step closer to reality, add in the mountains of Burma. That barrier to the east improves the pattern of rainfall, with more spilling over India itself. As a further complication for the model makers, the real monsoon can supply the moist air and yet fail to produce rain. That happens regularly in the desert region of northwest India, where rain seldom falls because the air is sinking. The monsoon can withdraw its gift of water. Rajasthan is the dry end of India. The hot breeze of the summer monsoon stirs the dust but delivers little rain. Among the arid scrubland, fortified cities like Bikaner stand out. In the worst years, the Maharaja might order a palace built just to provide work. The citizens of Bikaner defy a desert that seems to knock at the gates of their city. It wasn't always so. 4,500 years ago, the sand was submissive, even here, and the grass really grew. Archaeologists have argued fiercely about it. Was the climate once quite different in this corner of India and nearby Pakistan, when one of the first great farming civilizations sprang up? Did they just rely on rivers for irrigation, or did it rain? What may be crucial evidence comes not far from Bikaner, from a lake that's dried to salt. There's still brackish water left under the crust of salt. Gypsum mined from the salt lake goes to make plaster. If you dig a little into the disorderly deposits at the surface, you come to neater layers. They're studded with gypsum made by the lake as it dried. But the layers themselves formed when it was a lake of sweet water. Indian scientists have found pollen showing that bulrushes grew here, and from the surrounding land fell pollen of sagebrush and of trees such as Mytinus. For 1,000 years, the land blossomed under plentiful rain. The Indus civilization rose to splendor. Then the monsoon broke its promise. The civilization fell, to invaders, the history books say, but did the resurgent desert crush it first as it condemned the former farmlands to drought without end? Deserts are largely natural products of the world's overturning air, but some experts blame human beings for creating a pall of dust here. Stripping the land might prevent the moist air from rising and making clouds. But nature's actions can surpass mankind's mismanagement. When the Indus civilization flourished here, the world was very warm and rain-bearing winds were vigorous. Since then, amid little ice ages and warmer interludes, the trend's been downwards. While no one can fully explain the tropical drought and Arctic cold of our own times, Rajasthan says we must be wary of a cooling climate that turns human dreams to dust.